Hello everyone, welcome to my channel IGCSE and GCSE Maths School. I am Saman. Today we are going to do another important video on upper bound and lower bound of corrected values. Here before I have done several videos on rounding of numbers to nearest unit, nearest 10, nearest 100 and nearest 1000, and rounding of numbers to decimal places and rounding of numbers to significant figures. Now today's video is upper bound and lower bound of a corrected value. Now we will see straight away, we will go to the video. Right, in this video I expect to discuss three important points. One is upper bound, other one is lower bound, other one is the range of actual values that can be rounded to a given corrected value to the given degree of accuracy. Right. There are 3 points. Then first of all, the upper bound. The upper bound is the maximum value. The maximum value of the actual values that can be rounded to a given corrected value to a given degree of accuracy. What's the upper bound? Upper bound is the maximum value of the actual values that can be rounded to a given corrected value to the given degree of accuracy. Then the upper bound is the maximum value of the actual values that can be rounded to a given corrected value to a given degree of accuracy. So therefore now it is the maximum value. Therefore any value greater than or equal to the upper bound cannot be rounded to the given corrected value to the given degree of accuracy. Therefore, as maximum, this upper bound is the maximum value of the actual values that can be rounded to the given corrected value to the given degree of accuracy. Any value greater than the actual the upper bound cannot be rounded to the given corrected value to the given degree of accuracy. That is about the upper bound. Then the lower bound. The lower bound is the minimum value of the actual values that can be rounded to the given corrected value to the given degree of accuracy. Lower bound is the minimum value of the actual values that can be rounded to the given degree of given corrected value to the given degree of accuracy. Then the lower bound is the minimum value. The lower bound is the minimum value for any value less than the lower bound cannot be rounded to the given corrected value to the given degree of accuracy. Therefore, as the lower bound is the minimum value of the actual values that can be rounded to a given corrected value to a given degree of accuracy, any value less than the minimum value cannot be rounded to the given corrected value to the given degree of accuracy. So that's about the lower bound. So now therefore, upper bound is the maximum value, lower bound is the minimum value. Therefore there must be a range of values between upper bound and the lower bound that can be rounded to a given corrected value to a given degree of accuracy. So that range is limited by the lower bound from the lower side and from the upper bound on the higher side. So therefore, the range of actual values that can be rounded to a given corrected value to a given degree of accuracy can be written as lower bound less than or equals the actual value less than or equals the less than the upper bound. Lower bound less than or equals actual value less than the upper bound. Lower bound less than or equals actual value less than the upper bound. Therefore, the actual value that can be rounded to a given corrected value to a given degree of accuracy must be less than or equal to the lower bound. So must be more than or equal to the lower bound and less than the upper bound. Then the range of actual values. Any actual value that can be rounded to a given corrected value to a given degree of accuracy must be less than or greater than or equal to the lower bound, less than the upper bound. Greater than or equal to the lower bound, less than the upper bound. So that is here. That is what is given by this. The upper bound. The maximum value of actual values that can be rounded to the given corrected value to the given degree of accuracy. Any number greater than or equals upper bound cannot be rounded to the given corrected value to the given degree of accuracy. The lower bound. If you want, you pause the video and write down this note, right? Okay, then lower bound. Lower bound, the minimum value of actual values that can be rounded to the given corrected value to the given degree of accuracy. Then any number less than lower bound cannot be rounded to the given corrected value to the given degree of accuracy. Then, therefore, the range of actual values that can be rounded to the given corrected value to the given degree of accuracy is lower bound less than or equals actual value less than upper bound. That means the actual value must be greater than or equal to our lower bound but less than upper bound. The next one, right? So that is the basic points about that. Then I want to explain to you this actual value and the corrected value, the two concepts, actual value and the corrected value. Then take the actual value. For example, I take an example. I will explain that by an example like this. Like this. Here, we take say example. Say you are asked to, first of all, you are asked to say this one, 565. You are asked to, this is the actual value. Actual value. Then you are asked to write this correct to nearest 10. Then round that to nearest 10. Let's say nearest 10. This is nearest 10. Round to nearest 10. Then we have learned how to round off the numbers to nearest. Go to tens place. Look at the units place. If this is greater than or equal to 5, add 1 to this one. If this is less than 5, no addition, and write the number until the digit in the degree of accuracy and put zeros for the numbers. Right now, this one here, tens place. This is tens place. Then go to tens place as it is to be rounded to the nearest 10. And this is tens place. Go to the in place greater than 5. Add down to this one. This becomes 7, and this becomes 0. Then this is the answer. Correct to nearest 10. Right. It is the number correct to nearest 10. Then out of this number, this is the actual value. Then out of these two, 565, this is the actual value. This is the actual. This is the corrected value. What is that called? Corrected value. This is the corrected value. Correct. Now you know the difference between actual value and the corrected value. Right? That 570 is the value you got after rounding off. Then value you get after rounding off is called the corrected value. That original value, the given value, is called the actual value. Right? Okay. Next one. Right. Now, then we are going to consider now how to find the upper bound and lower bound. Upper bound, to find the upper bound and lower bound, you use two different formula. One formula for find the upper bound, other formula for finding the lower bound. Then the upper bound formula is corrected value. Upper bound equals corrected value plus degree of accuracy over 2. Then lower bound formula, lower bound equals corrected value minus degree of accuracy over 2. These are the two formulas. Upper bound formula equals corrected value plus degree of accuracy over 2. The lower bound formula, lower bound equals corrected value minus degree of accuracy over 2. So these are the two formulas you use to find what? The upper bound and lower bound. Right, now we'll take some examples. What are the examples? Here, I have got the examples here. Here 3000 is the corrected value. 3000 has been given as the corrected value. Then you have to find the upper bound and lower bound. We will take it. Then upper bound equals 3000. 3000 here given 3000, right? 3000 is the corrected value plus they have given the degree of accuracy 1000. Degree of accuracy 1000. They put here 1000 here. Then divided by 2. Then you get what? Answer how much? Here 3000. Here 1000 divided by 2, 500. That means 3500. 3500 is the upper bound of this case. Then second one. Then lower bound of that. Lower bound, you take lower bound. Lower bound of that. Corrected value is 3000 itself. Then minus. Then the degree of accuracy is given here nearest 1000. Therefore, 1000 is the degree of accuracy, that is divided by 2. Then here 1000, 3000, here 500. 3000 minus 500, 2500. 2500. Now next one, 2500. Then upper bound. Upper bound. Here 2500 is the corrected value. 2500. Then plus. They are the degree of accuracy nearest 100. 100 divided by 2. Then 2500 plus 100 divided by here 2500. 100 divided by 2 is 50. 2500 plus 50 is 2550. That is the answer for that. Then lower bound of that. Lower bound of that. You get again corrected value is 2500. 2500 minus. Then the degree of accuracy is 100. You put here 100 divided by 2. 100 divided by 2. 100 divided by 2 is 50. 2500 minus 50. How much? 2450. That is the lower bound. Right. Now you go to the next one. Next example. And I will take it here itself. Then here 1560. Then upper bound. This sorry, this is 3. This is 4. Right. Then this is we will say this is third one, upper bound. Upper bound, you know, equals this one, corrected value. Corrected value is 1560. Then plus degree of accuracy. Then degree of accuracy is given here nearest 10. Then 10 divided by 2. Then 150 plus 10 over 2. 10 divided by 2 is 5. Then 1560 plus 5 is 1565. Then upper bound. Then lower bound. Lower bound equals again the corrected value is 1550 minus lower. And degree of accuracy is 10 and divided by 2. Then 1560 minus 5. That means 1555. This is the answer of that. Then fourth one. This is 1. This is 2. Right. Then fourth one. Corrected value is upper bound. Corrected value is 1631. That is plus upper bound. The current degree of accuracy has been given as nearest unit. Unit means 1 over 2. Anyway, it says that the 151 correct nearest unit. That means the degree of accuracy nearest unit means degree of accuracy always taken as 1, right? Then here 1 divided by 2, that means 1631 plus half. That means 1631.5. Half means 0.5, right? Next one, lower bound of the fourth case. Then again the degree corrected value 1631 itself. Then minus, then lower bound means minus half. Minus half means you have to deduct 0.5 from this, then 1630.5. This is the lower bound of that. That is how you calculate the upper bound and lower bound of, these are some simple examples of how to calculate the upper bound and lower bound of corrected values. Then many examples are coming in the oncoming videos. Then that is all about today's video, but I want to tell you one thing, because I want to make a correction in one of the examples of the previous video. In the previous video, we did on the rounding of numbers to significant figures. That in that one, the 10th example, I have write it here itself. 10th example, the correction of the previous video, right? Here the 10th example was, write that 0.3 3050, that is correct to, you have write that correct to 2SF. This is 2SF. 2SF. You have to round these two significant figures. Then by mistake, I wrote this answer as 3100. That is wrong. I am going to correct it now. It should be not 3100. Now these are decimal. Then first this preceding 0 is not a significant figure. The significant starts from this 3. Then first significant figure, second significant figure, third significant figure. Right now, but we want to write the answer correct to two significant figures. Therefore, this is the second significant figure. The intervenient zeros are significant figures. The first significant, second significant. Go to this one and look at the digit in the place value just below the place value of the degree of accuracy. The place value of degree of accuracy is here. That is second decimal. And look at what is in third, that is 5. It is greater than, that is equal to 5. Therefore, you add 1 to this one, then answer will be 0.31. That is the answer. Therefore, please take note that mistake is corrected. That is mistake is in the previous video. I will, I'm mentioning the link of that video in the description of this video. So that is all about today's video, and I stop expectation of meeting you tomorrow with another interesting video on more examples of upper bound and lower bound of corrected values. Until that, say goodbye to you. Thank you.